What's up guys, Onmaths here, and we're looking at polygons today. So first question will be from AQA, and we're going to be looking at exterior angles. You could do this looking at interior angles, but you can answer this full question probably easier looking at exterior angles. And the first thing to do is get a nice line going up like that, and we're going to cut that angle into half. Now, because it says that the angle polygons are regular, it just means that all of the angles are equal. So therefore, the two exterior angles, this one and this one, will be equal as well. So those are both going to be 30. Whoops. 30. So they're both 30 degrees there. So the exterior angles of both of the polygons are going to be 30. Now, when you know the exterior angle of a regular polygon, you can actually work out the amount of sides because we've got the number of sides equals, and it's just going to be 360, because all exterior angles have to add up to 360 degrees, divided by the exterior angle. Simple as that. So divide 1 by 10 and you get 36 over 3, and then 36 divided by 3 is going to be 12. So n equals 12. Now that seems like really simple, and it seems like for question 14 on a higher paper, that's quite a nice easy one. I think that some people probably would have tried to do this looking at the interior angles, which is a longer way of doing it. So you do 360, take away 60 and then halve it, and then you've got to use the interior angle formula, which we'll look at later. But for this one, exterior angle's way easier. Next we move on to our OCRs offering, and we've got two tiles together. One tile, let's just highlight it. So one tile is a regular hexagon, and the other tile is a regular pentagon. So we've got two different shapes there. Show the angle A is 132. So again, two ways of doing this. We could work out the interior angles and do it that way, or we could work out, which we're going to do, just the exterior angles, which is going to be way easier. So again, what we want to do is cut this up like that, and we're going to cut this up into half, and we're going to look at the polygon here, and we're going to look at the polygon here, and we're going to work out the exterior angles of both of them, and then just add them together at the end, which is going to be simpler. So the left hand one is our hexagon, so that's got 6 sides. So to work out the exterior angle, so we'll say the hexagon. So the exterior angle is going to be 360 divided by the amount of sides, which is 6. So that's going to be, 60. Then we're going to work out the pentagon. So pentagon, and again, exterior angle is going to be 360, and the pentagon has 5 sides, so divide that by 5, which is going to be 72. And then we want to work out the total. So the total will be the 60 plus the 72, which is going to be 132 degrees. Nice and easy. Okay, so second question is actually much more difficult, only because we've got to do some calculations. It says Imran thinks that that another tile in the shape of a regular polygon will fit exactly into angle A. Is Imran correct? Right. So our length, or our angle that we've got in angle A is 132, which it gives us in the question as well, so we know it's right. And we've got to figure out whether a polygon can fit with an interior angle of 132. Now again, multiple ways of doing this, but if the interior angle is 132, we can easily work out the exterior angle. So exterior, and to find the exterior angle, interior and exterior angles are on a straight line, so they add up to 180. So we just do 180, take away 132, which is 48 degrees. So the exterior angle is 48. Now, we use the same formula as we did before, but this is a non-calculator paper, because OCR, their paper 5, is non-calculator. So we're going to have to do this without a calculator, which is, I think, the challenging part of it. So we just need to see whether 360 is a multiple of 48, because if it is a multiple, then it works perfectly. If it's not a multiple, then the polygon can't exist. Simple as that. So I'm just going to do a bit of struggle and do this without a calculator. So I know that 48 times 10 is 480, therefore 48 times 5 is going to be, what, 240. Then I'm just going to add on 48 times 6, which is, what, 288. We're getting close. So therefore 48 times 7 is 336. So just adding the 8 and then adding the 40, simple as that. And 48 times 8 is 384. So you can see that the 360 is trapped between these two. And I think it's probably going to be, looking at it, those are, so 360 is halfway between those, so it would be 48 times 7.5. Well, you can't get a polygon of 7.5 sides, so therefore the answer will be no. So no, the number of sides will be a decimal. So polygons must have an integer as their number of sides, and just always make sure to first of all answer the question, is everyone correct? No, but also add a little bit of a sentence about why. So I think it's 7.5, but I'm not going to write that down just in case I'm wrong. But you can clearly see here that it's trapped between 7 and 8, so it's going to be a decimal, and that's all I need to say. You could elaborate more, saying the number of sides will be decimal, therefore it cannot be a polygon. Simple as that. Just as long as you acknowledge you're working out, and it's really important for this question to show the working out, as always. Okay, last question up is the Edexcel, and this is a calculator paper, a calculator question, which is nice. So loads and loads of ways of doing this one. I'll show you a few suggestions, or a few ways I can think of. You can actually work out the exterior angle of polygon P by drawing a line here, find the interior angle of the 12-sided polygon, which I believe is called a dodecagon, and then take away the exterior angle of the square, which would be 90 degrees. That's absolutely fine. You could do the exterior angle of the square and add it to the exterior angle of the dodecagon, and that will give you the interior angle of the polygon, and work it out that way. I'm going to do the just interior angles for this, only because I haven't really done that. And it's worthwhile just going through how to work out interior angles. So I'm going to work out the interior angle of the 12-sided polygon, or the dodecagon, and we're going to do that by, so I'm going to write down 12-sided, show the mark of what I'm doing, and we're going to do the interior, and to do that we do the number of sides, take away 2, times 180, and then to work out what the actual side is, because it's regular, we just divide it by 12, simple as that. So we're going to do 10 times 180, so there's 12 sides, so 12 take away 2 is 10, and get my calculator out. So 10 times 180, obviously 1800, divided by 12 would be 150. So that's that part done. Right, next we'll move on to the square. So square, interior, obviously 90. Right, so to work out the polygon P, we're going to do, so angles on a point is 360, so 360 take away 150 plus 90. And we should say interior. I don't know whether I can actually move that. Oh, there you go. So interior. Okay, so get my calculator. 360 take away 150 plus 90. It's going to be 120. So the interior of polygon P is 120 degrees. So to work out the exterior, we take it away from 180, so 180 take away 120. Why am I doing that on the calculator? Obviously it would be 60. And then we do, so number of sides. And we use the formula we used before, so it's 360 divided by the exterior angle, which will be 60. Let's just move down. And that will be 6, which is good because we're trying to show that it is a hexagon, and hexagon has 6 sides, therefore we've shown it. Well, I hope today's video was useful. All the interior and exterior angles, or hopefully you can handle them. There's some basic formulas there, just the interior formula, n-2 times 180 to work out what the sum of the interior angles is, and then divide by the amount of sides if it's regular. If it's irregular, then you just have to work it out one by one. But the sum of interior angles still works. And then the exterior angles formula, 360 divided by exterior angles gives you the amount of sides. And the all-important one, that the interior and exterior always add up to 180 because they always appear on a straight line. If you did the questions any differently but got the right answers, there are loads and loads of different permutations of answering these questions. So don't feel like you're doing anything wrong. Chances are you're doing it absolutely right. It's just a different way of doing it. I hope you like this video. If you like it, please click like. If you want to see more from us, click subscribe. And make sure you check out our website onmaths.com, where there's loads and loads and loads of questions and support and all sorts of things to help you keep up with your maths, especially at this time. And thank you very much.